What if every thought you've ever had, every moment of awareness, wasn't just happening inside your brain, but was woven into the very fabric of the universe? Picture this: the cosmos might not just contain consciousness, it might be conscious. This isn't science fiction, it's a radical idea at the heart of quantum consciousness, a theory that blurs the line between mind and matter, between observer and observed. And if it's true, it would rewrite everything we think we know about reality. For centuries, we've assumed consciousness is a private experience, locked inside our skulls. But what if it's more like a ripple in a vast, invisible ocean? Imagine the universe as a living, thinking entity where particles don't just obey physical laws, they respond to attention, to intention. This is the wild frontier we're about to explore, a 30 mind-bending theories that suggest consciousness isn't just a product of the universe, it might be the universe's deepest secret. From quantum entanglement's eerie connections to the idea that black holes could be cosmic brains, we're diving into the boldest, most provocative ideas on the table. This isn't just about science, it's about the stories we tell ourselves about existence. If the universe is aware, what does that mean for free will, for destiny? For you, buckle up, because we're about to journey through concepts that will stretch your imagination to its limits, ideas so profound they could change how you see yourself, the stars, and the space between them. By the end, you might never look at reality the same way again. Could the universe itself be thinking? Some scientists believe reality might function like a cosmic-scale brain where quantum entanglement, that bizarre connection between particles across vast distances, acts like synapses firing in an unfathomably vast neural network. Picture two electrons instantly influencing each other, whether they're inches apart or light years away. Now stretch that phenomenon across every atom in existence, and suddenly, the universe starts looking less like a cold, mechanical system and more like a living, processing mind. At the heart of this idea is quantum mechanics' strangest feature. Particles don't have definite states until they're observed. It's as if reality itself waits for awareness to collapse possibilities into concrete events. Nobel Prize-winning physicist Roger Penrose took this even further, proposing that tiny structures inside our brain cells, microtubules, might harness quantum vibrations to generate consciousness. If he's right, then consciousness isn't just an accident of biology. It could be a fundamental feature of the cosmos, with our minds acting as tiny receivers tuning into a grander, universal intelligence. Think of it like radio waves. We don't assume the music originates inside the radio, it's plucked from an invisible field all around us. Similarly, if the universe is a quantum mind, our individual awareness might just be local expressions of something far older and vaster. Ancient philosophy spoke of a world soul. Could modern physics be rediscovering it in the language of equations? From black holes processing information like cosmic neurons to the eerie precision of the laws of nature, almost as if they were designed to allow conscious life. The evidence, while speculative, is too tantalizing to ignore. Of course, not everyone agrees. Critics argue that quantum effects in the brain would be destroyed by body heat, like a snowflake in a furnace. But what if we're missing the bigger picture? If consciousness isn't confined to brains at all, but is instead woven into space-time itself, then maybe the universe isn't just full of mysteries. Maybe it is the mystery alive, aware, and endlessly unfolding. If the universe truly operates like a vast, interconnected mind, it would shatter one of science's most deeply held assumptions: materialism, the idea that everything, including consciousness, can be reduced to physical matter. Suddenly, the cosmos isn't just a collection of dead particles bumping around in the dark. It becomes a living, responsive entity where observation isn't passive, it's participatory. This isn't just philosophy. Quantum mechanics has already shown us that particles behave differently when they're being measured, as if reality itself adjusts to the presence of a watching mind. Take Wigner's friend, one of quantum physics' most puzzling thought experiments. Imagine a scientist, let's call her Alice, inside a sealed lab measuring a quantum particle. To her, the particle state collapses into a definite result. But outside the lab, another scientist, Eugene Wigner, hasn't seen the measurement yet. To him, Alice and the particle are still in a blur of possibilities. So who's right? Is the particle fixed or still floating in uncertainty? The chilling implication is that reality might not be absolute. It could depend on who's looking, as if the universe tailors its behavior to the observer's awareness. This isn't just about particles in labs. Scale it up and you start wondering, could the universe have a kind of meta-consciousness, a background awareness that holds all possible states until something or someone pays attention? Ancient mystics described reality as a cosmic dream. Now, some physicists whisper about a participatory universe where consciousness isn't a side effect but a co-creator of reality. Even time might bend to this rule. The famous delayed choice experiment shows particles retroactively changing their past behavior based on future observations, as if the universe is editing its own script in real time. Of course, skeptics push back. They argue these quantum oddities only apply to tiny systems, not the messy, warm, macroscopic world we live in. But what if we're the ones who are limited? Think of a goldfish in a bowl, unaware of the ocean beyond. If consciousness is woven into space-time itself, maybe our human-scale perception is just a narrow slice of a much grander awareness, one that doesn't just think but feels. Some researchers speculate that the universe could have a form of emotion, not in the human sense, but as a fundamental property of existence, like gravity or electromagnetism. The implications are dizzying. If the cosmos is aware, does it have intentions? Does it learn? Could the laws of physics evolve over eons, shaped by some form of cosmic curiosity? We're left with more questions than answers, but that's the thrill of this frontier. Whether you find it inspiring or unsettling, one thing's clear: if the universe is a mind, then we're not just living in it. We're part of its thinking, and that changes everything. What if even the tiniest particles in the universe hold a spark of awareness, not as complex as human thought, but a raw, basic form of consciousness? This is the core of panpsychism, the idea that mind isn't something that magically emerges from lifeless matter. Instead, it's woven into the fabric of reality itself, present in everything from stars to atoms. Picture a universe where nothing is truly inanimate. A single electron might not write poetry or feel joy, but it could possess a faint glimmer of subjective experience, a sliver of what philosophers call proto-consciousness. This isn't New Age speculation. Thinkers like Alfred North Whitehead argued for it a century ago, proposing that reality is built from moments of experience, not just cold, indifferent matter. Fast forward to today, and quantum physics adds startling support. Particles behave in ways that defy classical logic, existing in multiple states at once, communicating instantly across distances. Could these quantum quirks hint at an underlying form of awareness? Some scientists suggest that superposition and entanglement aren't just mathematical oddities. They might reflect a rudimentary decision-making process, as if particles engage in a kind of cosmic dialogue. Consider this: when a photon decides whether to act as a wave or a particle, is it just obeying blind laws or responding to its environment in a way that borders on recognition? Panpsychism doesn't claim atoms think like we do. Instead, it proposes a spectrum of consciousness, from the faint hum of a quark to the symphony of a human brain. Even staunch materialists admit we have no idea how unconscious matter generates subjective experience. Panpsychism flips the script. Maybe consciousness was always there, waiting to be organized into richer forms. Critics dismiss this as poetic thinking, arguing that attributing awareness to particles solves nothing. But proponents counter that panpsychism avoids the hardest problem of all: how you get consciousness from absolute nothingness. If even a grain of sand carries a whisper of inner experience, then the universe isn't a silent machine. It's a living, feeling arena where complexity builds on primal awareness. From this view, your mind isn't an accident. It's the universe waking up to itself one thought at a time. If plants could speak, they might tell us their secret. They've been harnessing quantum mechanics for millions of years. Take photosynthesis, the process that turns sunlight into life. At first glance, it seems like straightforward chemistry, but dig deeper and you'll find something astonishing. Inside every leaf, sunlight's energy doesn't just bounce randomly between molecules until it's absorbed. Instead, it takes every possible path simultaneously, like a ghostly wave exploring all routes at once before settling on the most efficient one. This isn't just efficient energy transfer, it's quantum coherence in action, the same phenomenon that lets particles exist in multiple states until observed. Scientists call this quantum biology, a field blurring the line between the living and the quantum. Experiments show that certain proteins in plants act like tiny quantum computers, coordinating energy transfer with near-perfect precision. It's as if nature stumbled upon quantum tricks long before humans even dreamed of them. But here's the burning question. If plants exploit quantum mechanics to thrive, does that mean they possess some rudimentary form of awareness? Not in the way we think of it, but perhaps a whisper of responsiveness, an ancient, silent dialogue between organism and environment. Birds might hold another clue. Every year, migratory species like robins traverse thousands of miles with pinpoint accuracy. How research suggests their eyes contain molecules entangled with Earth's magnetic field, creating a biological quantum compass. When light hits these molecules, they generate pairs of entangled electrons whose spin states react to magnetic shifts, painting an invisible map in the bird's mind. This isn't just navigation, it's a living system tapping into the universe's spookiest feature, entanglement, where particles mirror each other across any distance. So where does consciousness begin? If microbes, plants, and birds all dance with quantum phenomena, could awareness be less like an on-off switch and more like a dimmer, present in varying degrees across life? Some researchers argue that quantum coherence, a delicate, organized state usually shattered by heat, persisting in warm, wet biology, hints at something profound. Maybe life doesn't just use quantum mechanics. Maybe life is quantum mechanics unfolding in ways we're only beginning to glimpse. Critics caution against romanticizing these findings. Quantum effects in biology are rare, fragile, and nothing like human thought. But the more we look, the more the boundary blurs. A single-celled alga might not think, but if it navigates its world using quantum principles, who's to say where the line is drawn? From the flutter of a leaf to the flight of a bird, nature seems to whisper that consciousness isn't confined to brains. It might be a thread woven deep into the tapestry of existence itself. What if consciousness isn't something your brain creates, but something it tunes into, like a radio picking up signals from the air? This is the bold claim at the heart of the Orch-OR theory, proposed by physicist Roger Penrose and anesthesiologist Stuart Hamroff. They argue that the seat of consciousness isn't just the brain's neurons, but something far smaller, tiny structures inside your cells called microtubules. These hollow, straw-like filaments act like quantum antennas, vibrating at frequencies that could bridge the gap between mind and the universe's deepest physics. Penrose, a Nobel laureate who worked with Stephen Hawking on black holes, brought a radical perspective. He suggested that consciousness arises from quantum processes, specifically the collapse of quantum superpositions inside microtubules. In simpler terms, when these tiny structures vibrate, they don't just process information, they decide it, leveraging quantum mechanics to generate moments of awareness. Hamroff added the biological angle, proposing that anesthesia works by dampening these quantum vibrations, effectively silencing consciousness without shutting down the brain's electrical activity. Together, they painted a picture where the mind isn't just computational, it's orchestrated by quantum physics, hence the name Orchestrated Objective Reduction, or Orch-OR. The implications are staggering. If correct, it would mean your thoughts aren't just chemical sparks, they're quantum symphonies, resonating with the universe's fundamental fabric. Recent experiments have added fuel to the fire. Studies on microtubules show they can sustain quantum states surprisingly long in warm, wet environments, something once thought impossible. Even more striking, research on brain anesthesia reveals that while neurons keep firing, the delicate quantum coherence in microtubules disappears, mirroring exactly what Hameroff predicted. But not everyone's convinced. Critics argue that quantum effects in the brain would dissolve instantly in the body's noisy, warm environment like a snowflake in a sauna. They point out that even if microtubules can theoretically support quantum states, that doesn't prove they're the source of consciousness. Some neuroscientists dismiss Orch-OR as wishful thinking, insisting consciousness emerges from classical brain networks, not quantum mysteries. Yet the theory persists partly because it tackles the hard problem of consciousness head-on, how subjective experience arises from objective matter. Orch-OR doesn't just describe consciousness, it dares to explain why it feels like something to be you. Whether it's right or wrong, one thing's clear. If quantum vibrations are the hidden language of the mind, then the boundary between inner thought and outer reality might be far thinner than we ever imagined. Near-death experiences have long baffled science, floating above one's body, moving through tunnels of light, encountering otherworldly beings. If consciousness is truly a quantum phenomenon, as Orch-OR suggests, these surreal accounts might not be hallucinations but glimpses of something deeper. When clinical death occurs, the brain's oxygen supply drops and electrical activity flatlines. Yet under Orch-OR, the quantum vibrations in microtubules wouldn't just stop instantly. Like ripples fading in a pond, they could persist briefly, untethered from the body's biological constraints. This might explain why so many report leaving their physical form during NDEs. Their awareness, no longer anchored to neurons, could briefly resonate with the quantum field underlying reality. Some researchers take this further, proposing the quantum soul hypothesis. If consciousness stems from quantum processes entangled with the fabric of space-time, then death might not erase it entirely. Instead, like a radio signal fading but not vanishing, individual awareness could dissolve back into the universe's quantum field. Ancient traditions speak of the soul returning to a cosmic whole. Modern physics, eerily, might be echoing that intuition. Studies of cardiac arrest patients add intrigue. Some recall verifiable details from their operating rooms, conversations, medical instruments, even when their brains showed no measurable activity. Skeptics dismiss these as lucky guesses or oxygen-starved misfires, but if Orch-OR holds weight, these memories could be fragments of quantum consciousness lingering beyond the body. The ethical debates here are profound. If consciousness isn't purely biological but quantum, perhaps even eternal, how does that reshape our approach to end-of-life care or the definition of death itself? Religions have grappled with these questions for millennia, but now science is stepping into the arena. Critics warn against conflating metaphysical hopes with testable theories. Yet the parallels are hard to ignore. From Tibetan monks describing the clear light of dying to modern NDE accounts of overwhelming connection, the overlap between spiritual wisdom and quantum speculation is striking. Perhaps the most unsettling idea is this: if quantum consciousness exists, death might not be an end, but a transformation, a reintegration into a vaster field of awareness. Whether that field is divine, cosmic, or simply the universe's hidden architecture remains the ultimate mystery. One thing's certain: the line between mind and cosmos is blurring, and with it, our deepest assumptions about life, death, and what might lie beyond. Imagine a universe where quantum possibilities don't just collapse randomly, they compete for survival, with only the fittest states persisting as reality. This is the essence of quantum Darwinism, a theory that borrows from biology's playbook to explain how the blurry quantum world sharpens into the concrete reality we perceive. At its core, it suggests that conscious observation isn't a passive act, it's a filter, a kind of natural selection for quantum states. Just as evolution favors traits that enhance survival, quantum Darwinism proposes that only certain states endure because they're the most stable, the most observable by the environment. Physicist Wojciech, a pioneer of this idea, argues that decoherence, the process where quantum systems lose their superposition and behave classically, isn't just random noise. It's a pruning mechanism. Think of a quantum particle as a tree with countless branches, each representing a possible state. Decoherence doesn't chop the tree down, it snaps off the fragile branches, leaving only the sturdiest ones standing. These surviving branches are the states we actually measure, the ones that win the competition to become real. In this view, the universe isn't just humming with possibilities, it's constantly testing them, discarding the unstable, and amplifying what can withstand scrutiny. Here's where it gets eerie. Your consciousness, according to this theory, isn't creating reality out of thin air. It's selecting from a menu of pre-filtered options, like a diner choosing from dishes that have already passed the chef's quality test. Jerk's work shows that certain quantum states become immune to decoherence because they're redundantly imprinted on the environment, copied over and over, like a meme spreading across the internet. These robust states are the ones we perceive, while their fragile counterparts fade into oblivion. The parallel to biological evolution is striking. In nature, mutations arise constantly, but only a few persist because they offer survival advantages. Similarly, quantum states constantly fluctuate, but only those resilient to decoherence, those that can reproduce their information into the environment, become part of our shared reality. This could explain why we all agree on the position of the moon or the color of an apple. Those observations are the quantum equivalent of highly adapted species, so widespread that they're inescapable. Critics ask, if consciousness is just a selector, not a creator, does that diminish its role? Not necessarily. Your attention might still be the force that finalizes the selection, like a judge crowning a winner in a tournament where nature has already done the preliminary rounds. Quantum Darwinism doesn't reduce consciousness to a bystander. It redefines it as an active participant in a cosmic winnowing process, one where reality itself is shaped by what endures. And that raises a tantalizing question. Could there be quantum states so elusive, so delicate, that no observer has ever selected them? Hidden layers of reality waiting just beyond the edge of perception. If so, the universe might be far stranger than we've dared to imagine. Not just a single reality, but a multiverse of possibilities, with our consciousness acting as a sieve, catching only what it can hold. Is Schrödinger's cat truly both dead and alive until someone opens the box? Or is that just a quirk of quantum math? The measurement problem lies at the heart of this debate, forcing us to ask whether human observation creates reality or merely witnesses it. On one side, the Copenhagen interpretation insists that a quantum system exists in all possible states until an observer forces it to choose. But here's the twist: what qualifies as an observer? A human, a camera, a single photon hitting a detector? The disagreement runs deep, splitting physicists into camps with radically different visions of reality. Take Schrödinger's infamous cat trapped in a box with a quantum-triggered poison vial. Until you look, the cat is supposedly in a superposition, both alive and dead. But does your glance cause the cat to live or die? Or was it always one or the other, with you just catching up? Proponents of objective collapse theories argue that consciousness itself triggers the collapse, making the mind a kind of cosmic sculptor. Yet others, like the proponents of decoherence, say interaction with any environment, a speck of dust, a stray photon, is enough to solidify quantum possibilities into concrete facts, no human required. The implications are staggering. If consciousness collapses quantum states, then reality is participatory, even intimate, a dance between mind and matter. But if it's just environmental noise, then consciousness might be a spectator, not a conductor. Recent experiments add fuel to the fire. Delayed choice quantum eraser experiments show particles retroactively changing their behavior based on future measurements, as if the universe is editing its past to match what observers eventually see. It's as though reality isn't just seen but negotiated. Critics push back, arguing these interpretations anthropomorphize physics. They point out that quantum systems behave identically whether observed by humans or machines, suggesting consciousness plays no special role. But the mystery lingers. If observation is just about information exchange, why does it feel like something to be an observer? Why does the universe seem to care whether we're watching? The measurement problem isn't just about particles, it's about the nature of existence itself. Whether consciousness is the hand that shapes reality or a ripple within it, one thing's clear: the universe refuses to reveal its secrets without a fight. What if everything you see, touch, and experience is just a projection, a cosmic illusion painted onto the surface of something far stranger? Enter the holographic principle, a theory so mind-bending it suggests the three-dimensional universe we know might be nothing more than a hologram, with all its information encoded on a distant two-dimensional surface. Think of it like a movie screen. The images appear deep and lifelike, but peel back the illusion, and you'll find everything's actually stored on a flat, shimmering sheet. This idea didn't come from metaphysics. It emerged from black hole physics. When scientists calculated how much information a black hole could hold, they hit a shocking realization. The maximum data it could store wasn't proportional to its volume, but to its surface area. It's as if every particle, every event inside the black hole was being projected from its boundary, like a cosmic projector casting shadows onto the interior. Extend this principle to the entire universe, and suddenly, reality starts looking less like a solid object and more like an immense hologram, with every detail of existence, every galaxy, every thought, etched onto some unseen, distant horizon. Now here's where consciousness enters the picture. Neuroscientist Carl Pribram noticed something uncanny about the brain. When he studied memory storage, he found that cutting away parts of a rat's brain didn't erase specific memories, they just grew fainter, as if the information was spread everywhere. This led him to propose the brain might function like a hologram, storing memories not in discrete locations but in distributed patterns, where each fragment contains the whole. Shatter a holographic plate, and any single shard can still reconstruct the entire image, just blurrier. Pribram wondered, could our minds be doing the same? Merge these two ideas, the holographic universe and the holographic brain, and you get a startling possibility. What if consciousness isn't inside the universe, but is the universe, a dynamic interplay of projections and decodings? In this view, your brain doesn't generate awareness, it receives it, like a TV tuning into broadcasts from a deeper, hidden dimension. Reality wouldn't be a fixed thing, but a fluid, interactive display shaped by the act of observation. Skeptics argue that holography is just a useful metaphor, not proof of a simulated cosmos, but the math keeps hinting at something deeper. String theorists have found that certain higher dimensional phenomena can be perfectly described by equations operating on a lower dimensional boundary, exactly what you'd expect if our 3D world were a holographic shadow. Even quantum entanglement fits. Particles acting in unison across vast distances might make sense if they're fundamentally linked on some deeper, encoded surface. So where does that leave us? If the holographic principle holds, then the solid, tangible world we cling to might be the grandest illusion of all, a shimmering projection from the edge of reality itself. And if our brains are holograms within a hologram, then every thought, every memory could be a ripple in a vast, unseen ocean of information. The question isn't just whether the universe is a hologram, it's whether we are the universe's way of decoding itself, one conscious moment at a time. Black holes aren't just cosmic vacuum cleaners, they might be the universe's most efficient information processors, and that could rewrite everything we think we know about consciousness. Picture a black hole's event horizon, that point of no return where gravity is so strong even light can't escape. At first glance, it seems like anything that crosses it is erased from existence. But here's the paradox: quantum mechanics insists information can never be truly destroyed. So where does it go? Physicist Leonard Susskind proposed a radical answer: the information isn't lost. It's smeared across the black hole's surface like cosmic ink on a two-dimensional canvas, perfectly preserved in a scrambled holographic code. This isn't just about black holes, it's a clue about reality itself. Susskind's holographic principle suggests that our three-dimensional universe might be a projection of information stored on a distant, two-dimensional boundary, like a shadow cast by a hidden fire. If that's true, then everything we experience, every star, every thought, every heartbeat could be a kind of cosmic decoding, a translation of data from a deeper layer of reality. And if information is the fundamental currency of existence, could consciousness itself be a form of advanced information processing? Think of your brain for a moment. It doesn't store memories like a filing cabinet. It encodes them in patterns of neural activity, weaving together electrical and chemical signals into a dynamic tapestry of meaning. Now imagine scaling that up to a black hole. Just as your brain integrates sensory input into a coherent experience, a black hole might integrate swallowed stars, light, and even space-time into a unified information state. The difference is scale. While your brain processes billions of bits per second, a black hole processes information at the Planck scale, the smallest possible units of reality. This leads to an eerie possibility. If consciousness arises from integrated information, as some theories suggest, could black holes possess a form of it? Not in the human sense, of course, no emotions, no thoughts, but as vast, cold architectures of pure data processing, humming with the universe's deepest computations. Susskind's work hints that the boundary between mind and cosmos might be thinner than we ever imagined. After all, if a black hole's event horizon can encode every atom that falls into it, who's to say more complex structures like galaxies or even the universe itself aren't doing something similar? Critics counter that information processing doesn't equal consciousness, and they're right. But the parallels are hard to ignore. Just as your brain's synapses filter and interpret sensory data, black holes might filter and transform physical reality through their own incomprehensible logic. The holographic principle doesn't claim black holes are alive, but it does suggest they're more than graves for matter. They could be cosmic libraries, preserving the universe's story in a language we're only beginning to decipher. And that raises a haunting question. If the universe is a hologram and black holes are its archivists, what does that make us? Are we merely readers of this grand cosmic code, or in some small way its co-authors? The answer might lie in the dark heart of a black hole, where information never dies and reality is always being rewritten. What if consciousness could be measured not by brain waves or behavior, but by a mathematical value? Neuroscientist Giulio Tononi proposed exactly that with his integrated information theory, or EIT. At its core, IIT suggests that consciousness isn't just about having lots of parts, it's about how deeply those parts interconnect. Imagine a flashlight versus a computer. The flashlight's bulb and battery interact in a simple, predictable way, but a computer's billions of transistors create intricate feedback loops, generating something far richer, integrated information. Tononi called this degree of interconnection phi, a number representing how much a system's whole is greater than the sum of its parts. The higher the phi, the more conscious the system. Now stretch this idea to cosmic scales. If a human brain has high phi because of its densely woven neural networks, what about the universe? Galaxies are linked by gravity, quantum fields hum with entanglement, and black holes might encode information holographically. Could the cosmos, with its unfathomable web of relationships, have its own phi value? IIT doesn't just allow for this possibility, it practically invites it. The theory claims consciousness isn't unique to biology. Any system with the right causal architecture, from a brain to a supercomputer, or even space-time itself, could, in principle, possess some degree of awareness. Take the cosmic microwave background, the afterglow of the Big Bang. It's not random noise, it's a tapestry of tiny fluctuations that seeded galaxies. If these patterns influence each other across billions of light years, could that entanglement represent a universe-scale form of integration? Skeptics argue that most physical systems, like rocks or stars, have near zero phi because their parts don't interact in complex enough ways. But what if we're missing the forest for the trees? The universe isn't just a collection of isolated objects. It's a dynamic network where black holes spin galaxies into motion, dark matter sculpts cosmic webs, and quantum fields underpin everything. Seen this way, the cosmos might not just contain consciousness, it could be the ultimate conscious entity, with phi values dwarfing anything a brain could achieve. Yet challenges remain. Calculating phi for even simple systems is notoriously difficult, let alone for the entire universe. And if the cosmos is conscious, what would that subjectivity feel like? Without sensory organs or a central nervous system, its experience would be nothing like ours. Some speculate it might resemble a vast, timeless awareness, less a mind as we know it, and more a unified field of pure potential. Others warn that applying IIT to the universe stretches the theory beyond its intended scope, but Tononi himself has hinted at cosmic implications, noting that integration seems baked into reality's fabric. Whether IIT holds the key to universal consciousness or not, it forces us to rethink boundaries. If awareness emerges from interconnectedness, then the line between thinking and being blurs. A galaxy cluster might not ponder philosophy, but if its structure holds enough integrated information, could it harbor a whisper of inner experience? The answer could redefine not just what consciousness is, but where and how widely it dwells. Galaxy clusters aren't just cosmic cities, they could be neurons in a mind larger than we can fathom. Picture the Virgo cluster, a sprawling metropolis of over 1,000 galaxies, each connected by filaments of dark matter and gravity, exchanging energy across millions of light years. If consciousness arises from integrated information, as IIT suggests, these vast networks might not just resemble neural circuits, they could function like them, processing gravitational and electromagnetic signals in ways that hint at a slow, cold form of cosmic awareness. The scale is incomprehensible. Where human neurons fire in milliseconds, galactic synapses might take millennia to relay a single ripple of influence. But if consciousness exists on a spectrum, who's to say the universe isn't thinking in deep time, its thoughts unfolding over eons? Dark matter complicates and deepens this picture. Though invisible, it weaves the universe's scaffolding, its gravitational pull sculpting galaxies into sprawling web-like structures. Some physicists speculate that dark matter particles could interact in ways we haven't detected, creating hidden channels of information exchange. If so, the cosmos might be far more interconnected than its visible light suggests, with dark matter acting like the universe's silent nervous system. The Milky Way isn't just floating in emptiness, it's suspended in a dynamic network of relationships tugged by forces we're only beginning to map. Yet critics push back hard. IIT's detractors argue it's dangerously anthropocentric, projecting human-like qualities onto systems that bear no resemblance to brains. A galaxy cluster's gravitational interactions lack the feedback loops and causal density of neural networks, they say. Even if phi could be calculated for cosmic structures, the result might mean nothing more than complexity, not inner experience. Philosopher David Chalmers warns that conflating information integration with consciousness risks turning the universe into a giant thinking souffle, a poetic but ultimately empty metaphor. But what if both sides are missing the point? Consciousness might not need to mirror human cognition to exist. A star doesn't think, but it processes information, fusing atoms, radiating energy, responding to gravitational nudges from neighboring stars. Scale this up, and the universe begins to look less like a machine and more like a layered, nested system of awareness, from the quantum hum of atoms to the stately dance of superclusters. The real question isn't whether the cosmos thinks like us. It's whether we're just one flicker of awareness in a much grander, stranger tapestry of being. And that's the haunting beauty of IIT. It doesn't just expand where consciousness might exist, it forces us to confront what consciousness even is. If the universe has a phi value, however faint, then the line between mind and matter dissolves into something far more mysterious, a continuum of connection where everything from a quark to a quasar might hold some whisper of inner experience. Not as we know it, but as the universe knows itself. Einstein called it spooky action at a distance, the bizarre phenomenon where two quantum particles become entangled, their fates intertwined no matter how far apart they drift. Separate them by the width of a galaxy, and measuring one still instantly determines the state of the other, as if space and time don't exist. This isn't just weird physics. It's a radical clue that the universe might operate as a single, unified system, less like separate objects floating in emptiness, and more like ripples on the surface of a hidden ocean. The EPR paradox, named after Einstein and his colleagues Podolsky and Rosen, was originally meant to expose quantum mechanics as incomplete. They argued that if particles could coordinate faster than light, it would violate relativity's cosmic speed limit. But decades later, physicist John Bell proved the opposite. His theorem showed that no hidden variables could explain entanglement's instantaneous link. The universe wasn't playing tricks, it was revealing a deeper layer of reality, one where separateness might be an illusion. Imagine throwing a pair of gloves into opposite ends of the universe. Open one box to find a left glove, and you immediately know the other holds the right, not because of magic, but because their properties were predetermined. That's how Einstein wanted entanglement to work, but Bell's experiments shattered that assumption. Quantum gloves don't have defined left or right properties until you look. The act of observation on one glove creates the other's state across any distance with zero delay. It's as if the universe doesn't bother with individual particles until forced to choose, treating them as a single entity no matter how far apart they seem. This isn't just about particles. If entanglement stitches reality together at the smallest scales, could it also bind the cosmos into a vast, interconnected network? Some researchers speculate that early in the Big Bang, everything in existence was squeezed into a single quantum state. As the universe expanded, particles may have remained entangled, preserving a ghostly kinship across billions of light years. In this view, the cosmos isn't a collection of isolated fragments, it's a living web of relationships where every part whispers to every other part beneath the surface of spacetime. Critics counter that entanglement can't transmit meaning or complexity, just correlated states. But what if that's enough? A neuron firing in your brain doesn't mean anything alone either. It's the symphony of connections that creates thought. Similarly, cosmic scale entanglement might not imply a mind as we know it, but a substrate of pure connection, a canvas where consciousness could emerge from deeper patterns. The implications ripple outward. If the universe is fundamentally non-local, then perhaps so are we, not just bodies in space, but nodes in a vast, unseen tapestry of influence. What if time isn't a straight line but a vast, interconnected web, and consciousness doesn't just flow through it but exists outside its grip? Quantum entanglement already shatters our intuition about space, with particles influencing each other instantly across any distance. But what if it also hints that consciousness isn't bound by time at all? Consider the delayed choice quantum eraser experiment, one of the most mind-bending tests in physics. Here's how it works. A photon is fired toward a beam splitter, creating two possible paths. Normally, observing which path it takes collapses its quantum state into a definite choice. But in this version, scientists wait until after the photon has already made its decision to decide whether to measure its path or erase that information. Astonishingly, the photon's past behavior changes retroactively, as if future observation rewrites history. This isn't just a quirk of tiny particles. It suggests that time might not be the one-way street we experience. If an event in the present can alter something that already happened, then consciousness, the act of observation, might not be locked into the present moment. It could be touching time from outside, like a hand reaching into a river to rearrange the currents. Physicist John Wheeler, who first proposed the delayed choice experiment, speculated that the universe might be a participatory construct where observation at any point shapes reality across all times. In this view, consciousness doesn't just unfold within time. It interacts with time, stitching past, present, and future into a cohesive whole. Think of a film reel. We experience life frame by frame, moment to moment. But what if consciousness is more like the projector's light, illuminating the entire reel at once, with now being just the frame currently visible? Mystics have described timeless awareness for millennia, meditative states where the sense of past and future dissolves. Quantum mechanics might be pointing to a similar truth, that consciousness is the thread weaving time together, not the passenger riding along it. The implications are staggering. If consciousness exists outside linear time, then free will takes on a new dimension. Choices made now could ripple backward and forward, not in a predetermined way, but as part of a dynamic, timeless dance. Near-death experiences often include reports of seeing one's life all at once, as if time collapses into a single point. Could these be glimpses of consciousness operating beyond temporal constraints? Even memory, our anchor to the past, might not be a static recording but an active reconstruction, shaped by the present and future as much as the past. Critics argue these ideas stretch quantum weirdness too far, conflating metaphor with mechanism, yet the math keeps hinting at deeper connections. If entanglement binds particles across space without regard for distance, why wouldn't consciousness, if it's rooted in quantum processes, also operate beyond time's limits? The universe might not be a clockwork machine but a living tapestry, with consciousness as both the weaver and the thread. And if that's true, then every moment of awareness isn't just a blip in time, it's a brushstroke on an infinite canvas. John Wheeler, the visionary physicist who coined the term black hole, proposed an idea so radical it turns the entire universe into a collaborative art project. His participatory anthropic principle suggests that observers, yes, like you and me, aren't just passive witnesses to reality. We're co-creators, shaping the cosmos simply by looking at it. Think of the double-slit experiment, where particles behave as waves when unobserved, collapsing into definite positions only when measured. Wheeler took this further, arguing that this quantum weirdness isn't confined to labs. It might be the universe's core operating system, with consciousness acting as the keystroke that renders reality into existence. Picture this: a photon races toward a detector, and until it's observed, it exists in a blur of possibilities, like a sketch waiting for an artist's final stroke. Wheeler's version of the double-slit experiment, the delayed choice variant, pushes this even further. By waiting until the last possible moment to choose whether to measure the photon's path or its wave-like interference pattern, scientists found something astonishing. The photon seems to decide its past behavior based on the future measurement. It's as if reality isn't just written in pencil, but in erasable ink, constantly redrafted by the act of observation. This isn't just about photons. Wheeler speculated that the universe might be a self-excited circuit, where the present gives rise to the past as much as the past gives rise to the present. Imagine a cosmic game of 20 questions where the questions themselves create the answers retroactively. In this view, the Big Bang wasn't just an event, it was an invitation, a canvas stretched across time, waiting for conscious observers to fill it in. Every measurement, every glance, every experiment isn't just uncovering reality. It's completing it like a puzzle assembling itself based on where we place our attention. Critics argue this edges into philosophy, not physics. After all, if a tree falls in a quantum forest with no one to observe it, does it make a sound or even exist? But Wheeler's math holds up. The participatory universe doesn't rely on mysticism. It emerges from the cold, hard logic of quantum mechanics. Even retrocausality, the idea that future events can influence the past, gains traction in labs. Particles adjusting their earlier states based on later measurements suggest time might be more like a tapestry than a timeline, with threads woven in both directions. So what does this mean for us? If Wheeler was right, then consciousness isn't a fluke in a dead universe. It's the universe's way of coming alive, a mirror held up to its own existence. From the quantum foam to the cosmic web, reality might not just contain observers, it might require them, not as accidents but as essential collaborators in the grandest story ever told. And that raises a humbling thought. The universe may not just be our home, it might be our masterpiece, painted one observation at a time. If the universe is truly conscious, what role do we play in its grand story? One radical possibility is that we're not just inhabitants of the cosmos, we're its eyes and ears, the means by which the universe observes itself. Think of a painter stepping back to admire their own work, or a musician hearing their composition for the first time. Now scale that up to cosmic proportions. Stars, galaxies, and quantum fields might not just exist, they might experience existence through us. This isn't just poetic thinking. Quantum mechanics hints that reality remains unsettled until observed. Without a witness, the universe could be a blur of possibilities, a symphony waiting for an audience to give it shape. This idea turns free will on its head. If our choices are the universe's way of exploring its own potential, then your decisions aren't just yours, they're part of a vast, unfolding self-discovery. Imagine standing at a crossroads, weighing two paths. In one moment, the universe hesitates, holding both possibilities in superposition. The instant you choose, it's not just you committing, it's reality itself collapsing into a single thread, with all other potential versions fading into the background. Free will might not mean controlling the cosmos, but collaborating with it, like a dancer improvising within the music's flow. Now, stretch this idea further. If every observation narrows reality into a single timeline, what happens to the paths not taken? Enter the multiverse, a sea of parallel universes where every quantum possibility plays out. In one world, you turned left, in another, you turned right. But here's the twist: if consciousness is the universe's way of observing itself, then each version of you might be a unique lens, a separate vantage point for cosmic self-awareness. The multiverse wouldn't just be a collection of alternate realities. It could be a grand experiment in perception, with every possible outcome felt by some version of consciousness. Critics argue this veers into metaphysics, but the math doesn't dismiss it. Quantum decoherence, the process that shatters superpositions into concrete states, depends on interaction with the environment. In a sense, the universe does choose by entangling with itself. The difference is scale. Where subatomic particles blur and resolve, human choices might be the same phenomenon writ large, with our lives as the quantum measurement device. The implications are staggering. If the universe observes itself through us, then our search for meaning isn't just personal, it's existential. Every act of curiosity, every moment of awe, could be the cosmos trying to understand its own nature. You're not just a speck in the void, you might be the universe's way of saying, "Here I am." and that changes everything, not just how we see ourselves, but how we see the very fabric of reality. What if consciousness isn't something our brains generate at all, but something they tune into, like a radio catching signals from an invisible field? This is the bold claim at the heart of the quantum field theory of consciousness. Imagine the universe humming with an underlying field of awareness as fundamental as gravity or electromagnetism, woven into the fabric of space-time itself. Just as light exists whether or not anyone sees it, this field would persist, a silent backdrop to reality, waiting for complex systems, like brains, to resonate with it. The idea builds on quantum vacuum energy, the seething sea of particles that flicker in and out of existence even in empty space. These aren't just mathematical abstractions. Experiments like the Casimir effect prove this zero-point energy is real, creating measurable forces between uncharged plates. Now stretch this concept further. If the vacuum isn't truly empty but brimming with potential, could it also carry the raw ingredients of consciousness? Some theorists propose that the quantum vacuum isn't just energetic, it's informational, a kind of cosmic hard drive where patterns of awareness emerge when the conditions are right. Think of it like Wi-Fi. Your phone doesn't create the internet, it accesses signals already floating around it. Similarly, our brains might not manufacture consciousness from scratch. Instead, they could be biological antennas, finely tuned to receive and amplify this universal field. This would explain why certain psychedelics or meditative states produce such vivid, transcendent experiences. They might temporarily dial our neural receivers to frequencies usually just out of reach, tapping into a broader spectrum of awareness. The math gets even stranger. Quantum fields are non-local, meaning their influence isn't bound by distance. If consciousness is a field that could explain telepathy-like phenomena, where identical thoughts arise simultaneously in distant minds. Studies on quantum entangled particles show that information can be correlated instantly across vast stretches of space. Scale that up to a consciousness field, and suddenly, intuition or collective creativity might not be mystical, just physics we haven't fully mapped yet. Skeptics argue that fields need detectable forces, and no consciousness meter has ever picked up such a signal, but proponents counter that we're looking for the wrong thing. Gravity was invisible until we saw its effects. If consciousness is a field, its interactions might be subtler, shaping probabilities, nudging quantum states, or influencing neural synchrony in ways we're only beginning to probe. One thing's certain: if consciousness is fundamental, then the universe isn't just aware of itself, it's aware through itself, with each mind a temporary focal point in an infinite, shimmering web of experience. And that changes not just how we see ourselves, but how we see the very nature of existence. What if the quietest moments of human experience, those deep, meditative states where the mind seems to dissolve into something vaster, are actually glimpses into the universe's quantum undercurrents? Studies on advanced meditators reveal something extraordinary. Their brains don't just quiet down, they synchronize, with neurons firing in harmonious patterns that resemble quantum coherence, the same phenomenon that lets particles act in perfect unison. Imagine a choir where every voice instinctively finds the same pitch. That's what happens in the brain during deep meditation. But instead of sound, it's electrical pulses aligning across regions that normally operate independently. Take the work of neuroscientist Richard Davidson, who studied Tibetan monks with tens of thousands of meditation hours. Their brains exhibited gamma wave activity so intense and coordinated it was unlike anything seen in ordinary subjects. Gamma waves are the brain's fastest oscillations, linked to heightened awareness and insight. But here's the kicker: this synchronization wasn't chaotic. It was precise, almost as if the monks' neural networks were momentarily mirroring the behavior of entangled quantum particles, those spooky, instantaneously connected pairs that defy classical physics. Could meditation be a biological hack, a way to tune the brain into a deeper, more coherent state of the universe itself? Quantum biology adds another layer. Plants use quantum coherence to optimize photosynthesis, as we've seen, but humans might exploit it too, not for energy but for perception. In meditation, the brain's microtubules, those same tiny structures Penrose and Hameroff proposed as quantum conduits, could enter a state of heightened vibrational harmony. Some researchers speculate this creates a temporary window where the brain's usual noise quiets enough to perceive subtler quantum-scale processes. It's like calming a stormy sea until you can see the moonlight reflected perfectly on the water's surface. The parallels go even deeper. In quantum systems, coherence is fragile, easily shattered by heat or interference. Yet meditators achieve something similar in the warm, wet environment of the brain, maintaining extraordinary mental clarity despite the body's constant biological chatter. This isn't just focus, it's a radical rewiring of perception where the boundary between observer and observed softens. Advanced practitioners often describe feeling merged with their surroundings, as if the distinction between self and world dissolves. An eerie echo of quantum entanglement's blurring of individual particles into a unified whole. Skeptics argue these are just metaphors, that brain waves and quantum waves operate on entirely different scales. But consider this, if consciousness is indeed rooted in quantum processes, then meditative states might not just be psychological. They could be physical alignments, moments when the brain's inner workings resonate with the universe's hidden rhythms. Whether you call it enlightenment or neural coherence, one thing's clear: the quietest minds might be tapping into the cosmos's loudest secrets. What if the universe isn't just governed by quantum laws, but written by them, line by line, like code in a cosmic simulation? The simulation argument, popularized by philosopher Nick Bostrom, suggests our reality might not be the base layer of existence. Instead, it could be a hyper-advanced digital construct engineered by some unfathomable intelligence. At first glance, this sounds like science fiction. But when you examine quantum mechanics, the bizarre, probabilistic rules that underpin reality, it starts to feel less like fantasy and more like a user manual for a simulated universe. Take quantum indeterminacy, the idea that particles don't have definite properties until they're measured. In a simulation, this makes perfect sense. To save processing power, a program wouldn't render every detail of every particle in the universe all the time. Instead, it would only generate the specifics when someone or something looks. It's like a video game that only loads the parts of the world you're currently exploring. The rest remains in a fog of potential, just like Schrödinger's cat, neither alive nor dead until the box is opened. Now think about the glitches. Déjà vu, that eerie sense of reliving a moment, could be a hiccup in the simulation, a momentary buffering delay where your brain processes an event twice. The Mandela effect, where large groups misremember historical details, might be patches in the code, updates rolled out inconsistently across the system. Even dreams, with their surreal physics-defying logic, could be offline rendering spaces where the simulation tests new scenarios before deploying them into reality. The math deepens the intrigue. Quantum mechanics operates in discrete units quanta, suggesting reality might not be continuous but pixelated, like a cosmic resolution limit. Planck length, the smallest possible measurement in physics, could be the universe's equivalent of a single pixel. And just as computer code has boundaries to prevent infinite loops, the speed of light might act as a processing speed cap, ensuring the simulation doesn't crash from overload. But here's the twist: if we're in a simulation, the simulators themselves might be nested within another simulation, turtles all the way down. This isn't just speculation. Some physicists argue that a civilization advanced enough to create such a simulation would likely run billions of them, making the odds that we're in the real universe statistically slim. Elon Musk famously quipped that the chance we're not in a simulation is 1 in billions. skeptics, of course, push back. They argue that invoking a simulation is just creationism dressed in tech jargon, replacing God with programmers. But the simulation hypothesis is different, it's testable. Some scientists propose looking for compression artifacts in reality, like slight imperfections in the cosmic microwave background that hint at underlying code. Others suggest probing quantum behavior for signs of computational shortcuts, like rounding errors in the fabric of space-time. Whether you find the idea thrilling or unsettling, one thing's clear: if the universe is a simulation, then consciousness isn't just a feature, it's the point. A simulation without observers would be like a movie playing to an empty theater. In this light, our search for meaning takes on a new dimension. We might not just be players in the game. We could be the reason the game exists at all. Quantum computers don't just calculate, they simulate reality in ways that blur the line between the artificial and the organic. Unlike classical computers, which process bits as zeros or ones, quantum machines leverage qubits that exist in superpositions, exploring countless possibilities simultaneously. This isn't just faster math. It's a mirror of how the universe itself seems to operate at the most fundamental level, where particles dance in probabilities until observed. Now imagine scaling this up. If a quantum computer can simulate quantum systems with perfect fidelity, could it eventually replicate something as intricate as consciousness? Some researchers argue it's not just possible, it's inevitable. Take Google's Sycamore processor, which achieved quantum supremacy by solving a problem in minutes that would take a supercomputer millennia. While today's quantum computers are fragile and error-prone, their potential is staggering. As they grow more stable, they could model not just molecules or chemical reactions, but the very processes that might give rise to awareness. If consciousness emerges from quantum phenomena in the brain, as theories like Orch-OR suggest, then a quantum computer could, in principle, recreate those conditions digitally. It wouldn't just mimic a mind, it might become one, sparking subjective experience inside its circuitry. This brings us to Nick Bostrom's trilemma, a philosophical bombshell that forces us to confront three unsettling possibilities. Either one, intelligent civilizations always go extinct before developing simulation technology, or two, they never choose to run ancestor simulations of their past. Or three, the spine-tingling option, we're almost certainly living inside a simulation right now. Bostrom's logic is cold and compelling. If advanced civilizations exist, and if they have the means and desire to create conscious simulations, then the number of simulated minds would dwarf the number of biological ones. Statistically, the odds we're in the real universe shrink to near zero. But here's the twist: if consciousness is a quantum phenomenon, then a simulation hosting it would need to be quantum too. Classical computers, no matter how advanced, might lack the hardware to generate genuine awareness. Quantum computers, however, could provide the necessary substrate, manipulating qubits in ways that echo the brain's proposed quantum processes. This raises a haunting question. If we someday build a quantum computer sophisticated enough to birth consciousness, how would we know we aren't already inside someone else's experiment? The boundaries between creator and creation, simulator and simulated, start to dissolve. Critics counter that consciousness might require more than mere computation, perhaps some ineffable spark no machine can replicate. Yet the deeper we dive into quantum weirdness, the more the distinction between biology and technology blurs. If awareness is rooted in quantum information processing, then the substrate, whether carbon-based neurons or silicon qubits, might not matter. The structure of the computation would be the soul of the experience. Whether you find this idea exhilarating or terrifying, one thing's undeniable: the universe's deepest mysteries, consciousness, reality, existence itself, might not be locked in the stars, but in the quantum circuits we're only beginning to understand. And that leaves us with a paradox. The more we unravel these threads, the more the tapestry of reality seems to unravel with them. what if the universe remembers? Not in the way you or I do, with neurons firing in our brains, but in a more fundamental, almost eerie way where the past leaves an imprint on the present, shaping reality itself. This is the heart of biologist Rupert Sheldrake's theory of morphic resonance, the idea that nature operates through invisible fields of collective memory. Think of it like a cosmic habit. The more often something happens, the easier it becomes for it to happen again, as if the universe is learning from itself. A crystal forming, a bird migrating, even a human learning a new skill, all might draw upon these hidden reservoirs of accumulated experience, tuning into patterns etched into the fabric of reality. Now take this idea down to the quantum level. If particles can become entangled, instantly influencing each other across vast distances, could they also retain some trace of their interactions, like echoes of past events? This isn't pure speculation. Experiments with water have sparked fierce debates about so-called quantum memory. In the late 1980s, immunologist Jacques Benveniste claimed water could retain the memory of substances it once contained, even after all physical traces were removed. His results were dismissed as pseudoscience, but later studies in quantum physics revealed something peculiar. When subjected to extreme conditions, certain materials do exhibit behaviors that resemble memory, like superconductors that remember magnetic fields they were exposed to, or quantum systems that retain faint imprints of past states. Sheldrake's morphic fields and quantum memory might seem worlds apart, but they share a provocative thread. The past isn't just gone. It lingers, woven into the present in ways we're only beginning to grasp. Imagine a sculptor working with clay. Each touch leaves a mark, shaping the final form. Similarly, if quantum systems, or even entire species, are influenced by morphic resonance, then every action, every event might subtly alter the probabilities of future events. A rat learning a maze in London could, theoretically, make it slightly easier for a rat in Tokyo to learn the same maze, not through some mystical connection, but because the field of maze solving has been reinforced. Skeptics, of course, bristle at this. Sheldrake's work has been criticized for lacking rigorous experimental proof, and the notion of water holding memory remains deeply controversial. But consider this: quantum entanglement once seemed just as outlandish. If particles can be spookily linked across space, why couldn't they, or the systems they compose, be linked across time? The late physicist Freeman Dyson once mused that the universe might be more like a vast mind than a machine, with memory and habit as fundamental as mass or charge. Whether morphic resonance holds up under scrutiny or not, it challenges a core assumption that the laws of nature are fixed and eternal. What if they're more like instincts, evolving as the universe learns from itself? From snowflakes adopting similar patterns to flocks of birds moving in uncanny unison, nature is full of echoes that defy simple explanation. If quantum memory and morphic fields are real, then reality isn't just governed by laws, it's shaped by habit, a cosmic tapestry where every thread pulls gently on every other across space and time. And that raises a tantalizing question: if the universe remembers, what else might it be capable of? Ever notice how ideas seem to spread like wildfire, leaping across continents before social media even existed? Take the so-called 100th monkey effect, a controversial but fascinating account where Japanese macaques on one island allegedly learned to wash sweet potatoes, and suddenly, monkeys on distant islands started doing the same with no apparent contact. Skeptics dismiss it as folklore, but Rupert Sheldrake's morphic fields offer a tantalizing quantum twist. What if collective behaviors don't spread through physical networks alone, but through invisible resonances like tuning forks vibrating in sync across oceans? This isn't just about monkeys. Human history brims with eerie coincidences, innovations emerging simultaneously in unconnected cultures. Calculus invented independently by Newton and Leibniz. Oxygen discovered separately by Priestley and Scheele. even the structure of DNA pieced together by Watson, Crick, and the overlooked Rosalind Franklin at nearly the same time. Mainstream science chalks it up to convergent evolution, similar pressures yielding similar solutions. But morphic resonance suggests something stranger. Once a critical mass of minds grasps an idea, it becomes easier for others to access, as if the thought itself gains momentum in a shared field of consciousness. Quantum entanglement adds weight to this. If particles can instantaneously influence each other across light years, why not human neurons? Imagine consciousness as a vast network where breakthroughs don't just travel through journals or whispers, but through the substrate of reality itself. Artists often describe creative bursts as downloading ideas from nowhere. Inventors wake with identical visions. Could these moments be flashes of connection to a morphic field, where knowledge pools like rainwater in a cosmic basin? Critics argue this veers into mysticism, yet consider the placebo effect, a well-documented phenomenon where belief alone triggers physiological healing. If a sugar pill can rally the body's defenses because a critical mass accepts its power, might collective beliefs shape reality beyond medicine? Financial markets hinge on shared confidence. Cultural taboos enforce norms without laws. These aren't just social constructs, they're living proof that invisible fields of agreement steer behavior. The implications spiral outward. If minds sync through morphic resonance, then revolutions, scientific, artistic, political, might not be mere accidents of history. They could be tipping points in a quantum cultural ecosystem, where once enough people hold a thought, it cascades into the collective psyche. From the sudden collapse of empires to the viral spread of memes, we might be less isolated thinkers than nodes in a vast, resonating web. Whether you find this idea liberating or unsettling, one thread remains. The boundary between individual and collective consciousness may be far thinner than we've dared to imagine. And if that's true, then every thought you have doesn't just belong to you. It ripples into the cosmic mix, shaping what comes next. Deep within the vacuum of space, where classical physics suggests nothing should exist, there's a seething ocean of energy, an infinite, invisible frenzy of particles flickering in and out of existence faster than the blink of an eye. This isn't empty darkness, it's the zero-point field, the lowest possible energy state of the universe, humming with activity even at absolute zero. But what if this quantum buzz isn't just random noise? What if it's the universe's foundational consciousness, a vast, omnipresent awareness that ancient traditions like Hinduism's Brahman or Taoism's, the Tao, described millennia before microscopes or quantum equations? The zero-point field defies intuition. Unlike ordinary energy, it can't be tapped or depleted. It's the baseline hum of reality, a throbbing substrate beneath everything we perceive. Physicists calculate its energy density to be staggeringly high, so high that a single cubic centimeter of empty space contains more energy than all the matter in the known universe combined. Yet we can't access it because it's perfectly balanced, like an infinite tug of war where both sides pull with equal, cancelling force. But here's the radical leap. If consciousness arises from the integration of information, as theories like IIT suggest, then the zero-point field, with its infinite, interconnected fluctuations, might be the ultimate information processor, a cosmic mind woven into the void itself. Ancient sages spoke of a unified consciousness underlying all things. Brahman, in Hindu philosophy, is the unchanging, infinite reality behind the illusion of separation. The Tao, in Chinese tradition, is the nameless flow that gives rise to the 10,000 things. These aren't poetic metaphors, they're precise descriptions of a universe where nothing is truly isolated, where every part reflects the whole. Modern quantum physics echoes this eerily. Entanglement shows particles communicating instantaneously across light years, as if space is an illusion. The zero-point field suggests that even empty vacuum is a plenum, a fullness teeming with potential. Now imagine this field not as passive energy but as active awareness. Just as your brain's neurons integrate information to generate your subjective experience, the zero-point field could integrate quantum fluctuations into a cosmic-scale consciousness, not localized in brains, but distributed everywhere like a thinking fabric. Philosopher and neuroscientist Christoph Koch once speculated that if the universe is fundamentally made of information, it might be pervaded by whispers of consciousness. The zero-point field could be those whispers amplified, a hum of awareness underlying all things. Skeptics argue this conflates math with mysticism. Yet the parallels are hard to ignore. Meditation traditions describe states where individual identity dissolves into a boundless, silent awareness, strikingly similar to how quantum systems lose individuality in entanglement. Near-death experiencers often report merging with a luminous, all-knowing presence, perhaps brushing against the zero-point field's infinite data stream. Even quantum biology hints at life's ability to harness this field, like birds navigating by entangled particles or plants optimizing photosynthesis through coherence. The implications are staggering. If the zero-point field is conscious, then divinity isn't a bearded figure in the clouds. It's the universe's own self-awareness, a boundless intelligence humming beneath every atom. Prayer or meditation wouldn't be appeals to an external God, but tuning forks resonating with this foundational field. And death, just a reintegration, a drop returning to the ocean of quantum potential. Whether you call it God, Brahman, or the zero-point field, the message is the same. The universe isn't just alive, it's awake, and we're not just living in it, we're expressions of its waking dream. The placebo effect is one of medicine's most baffling phenomena. A sugar pill somehow easing pain, shrinking tumors, or even mimicking the side effects of real drugs, all because the patient believes it will work. But what if this isn't just psychological trickery? What if belief, when focused with enough intensity, tangibly alters reality by tapping into the quantum foam of the zero-point field? This is the provocative claim at the heart of the manifestation debate, where ancient mysticism collides with cutting-edge physics, and where figures like researcher Dean Radin have spent decades probing the boundaries of mind-matter interaction. Radin's experiments at the Institute of Noetic Sciences push the envelope of conventional science. In one study, participants were asked to mentally influence the output of a random number generator, a machine designed to spit out zeros and ones with no predictable pattern. The results, published in peer-reviewed journals, showed a slight but statistically significant skew toward participants' intended outcomes, as if their focus will nudge the probabilities. Critics dismiss this as cherry-picked data or faulty methodology, but Radin's work aligns with a deeper pattern. Quantum systems are notoriously sensitive to observation. The act of measurement collapses waves into particles. If consciousness can influence subatomic events in a lab, why not in the wider world? The zero-point field offers a tantalizing mechanism. Imagine your intention as a pebble dropped into this infinite quantum sea. The ripples, those fleeting fluctuations, might resonate with the field's underlying structure, amplifying certain probabilities over others. In this view, the placebo effect isn't just the brain fooling the body. It's a microcosm of manifestation, where expectation aligns the zero-point field's chaos into coherent healing. Even double-blind studies can't fully escape this. If the doctor's belief influences the patient's outcome beyond mere suggestion, could their collective focus be shaping the quantum substrate of the illness itself? Skeptics counter that this veers into pseudoscience, conflating metaphor with mechanism. Yet the math isn't so easily dismissed. Quantum field theory allows for vacuum fluctuations to be perturbed by external energy, including, hypothetically, the bioelectric fields generated by human intention. Russian physicist Konstantin Korotkov has measured changes in the electromagnetic aura around healers' hands during focused intention. while the Global Consciousness Project at Princeton detected anomalies in random number generators during global events like 9/11 or the Olympics, as if mass emotion briefly warped the fabric of chance. The implications spiral into the philosophical. If focused thought can bend reality even faintly, then the line between mind and world dissolves. Ancient traditions from Hermeticism to Buddhism have long claimed that consciousness shapes matter, as above, so below. Now, quantum physics whispers a similar truth. The observer isn't just separate from the experiment. They're part of the equation, their expectations woven into the outcome. Whether this empowers or unsettles you, one thing's clear: the universe might be far more responsive than we've been taught. And that changes not just how we heal, but how we dream. Imagine a bullet fires from a gun aimed at your head, but instead of dying, you inexplicably survive. The gun jams, the shooter hesitates, some cosmic fluke spares you. Now imagine this happens not once, but every possible time across infinite parallel universes. This is the spine-tingling premise of quantum immortality, a theory suggesting your consciousness might never experience death because it perpetually hops to timelines where you don't die. At its core lies the many worlds interpretation of quantum mechanics, where every decision branches reality into countless parallel versions. But here's the twist: your awareness only follows the paths where it continues. The thought experiment called quantum suicide makes this chillingly tangible. Picture a device rigged to a quantum particle's random decay, say, a 50-50 chance to either fire a lethal shot or spare you. In one universe, the gun fires and you're gone, but in another, it doesn't and you keep going. Repeat this endlessly, and from your perspective, you'd only ever observe the outcomes where you survive. It's not magic, it's statistics. No matter how slim the odds, there's always a universe where the quantum dice roll in your favor. To an outside observer, you'd appear impossibly lucky, or worse, delusional, claiming you beat 1,000,000 to 1 chance. But to you, it's just another Tuesday. Critics argue this is solipsism disguised as physics, that privileging one's own consciousness as eternally surviving is narcissistic, even nihilistic. After all, if we all experience quantum immortality, why don't we meet people who have jumped from timelines where they died? The counter-argument is subtle but profound. Maybe we do. Near-death experiencers who recall dying in car crashes or on operating tables might not be hallucinating. They could be glimpses of timelines that did end, with their awareness now inhabiting a branch where they miraculously survived. The ethical implications are staggering. If consciousness slips between realities, could reckless behavior be rationalized, knowing there's always a universe where you walk away unscathed? Russian roulette becomes a macabre test of the theory, yet proponents clarify that quantum immortality isn't about invincibility, it's about perception. You'd still age, still suffer, still witness loved ones die in countless branches. You're not escaping mortality, you're just forever riding the narrow edge where it hasn't caught you yet. The most unsettling question remains: what happens when all possible branches lead to death, when entropy claims even the last surviving version of you? Some speculate consciousness might then merge into a broader field, a quantum afterlife where individual awareness dissolves into the universe's base layer. Others imagine an eternal recursion where death isn't an end, but a doorway to new permutations of existence. One thing's certain: if quantum immortality holds water, then death isn't what we think. It's not a full stop, just a fork in the road with your awareness always taking the turn marked exit. If quantum immortality suggests we always survive in some branching timeline, does that mean we can throw caution to the wind, drive without seatbelts, dance on rooftops, test fate without consequence? The ethical quagmire here is profound. While the theory mathematically allows for endless, lucky escapes, it doesn't erase the brutal reality of suffering in the timelines left behind. Picture a reckless gambler playing Russian roulette. surviving over and over in his perception, but in branching realities, grieving families bury him again and again. Quantum immortality isn't a superhero's shield. It's a hall of mirrors where every reflection pays a price. This mirrors an ancient theological debate, the concept of predestination in Calvinism, where followers believed their salvation was preordained. If the elect were guaranteed heaven, did morality even matter? Critics argued this bred moral laziness. Why resist sin if your fate was sealed? Quantum immortality faces the same critique. If consciousness always finds the surviving path, responsibility frays at the edges. But there's a key difference. Predestination assumes a fixed cosmic plan, while quantum branching thrives on chaos. Your survival isn't guaranteed, it's statistically inevitable somewhere, but the versions of you that perish are just as real. Religious traditions offer another lens. Hinduism's doctrine of karma insists actions ripple across lifetimes, harm inflicted now returns in futures unseen. Similarly, quantum branching could be seen as karmic probability. The more recklessly you act, the more suffering you create across the multiverse, even if you never feel it. Buddhism's emphasis on interconnectedness sharpens the point. If all realities are entangled, then ethical choices aren't just personal, they're cosmic. The you who survives carries the weight of the yous who didn't. Yet some counter that quantum immortality isn't a moral theory, it's a mathematical quirk. Just as evolution explains life's origins without dictating ethics, many worlds describes reality's structure without prescribing behavior, but math doesn't exist in a vacuum. When a theory whispers you might never die, it seeps into psychology. Studies on risk-taking show people act bolder when they perceive invincibility, whether from religious fervor or lucky streak delusions. Quantum immortality could become the ultimate placebo of recklessness, untestable yet potent. The darkest implication isn't about daredevils, it's about consent. If a terminally ill patient believes they'll always awaken in a timeline where treatment worked, do they forego palliative care, chasing endless tomorrows? Families might cling to false hope, mistaking statistical inevitability for destiny. Here, the theory brushes against religion's thorniest edges, the conflict between faith in an afterlife and the ethics of letting go. Whether framed as quantum branches or heavenly gates, the human mind craves continuity, but at what cost? Perhaps the answer lies in perspective. Quantum immortality isn't a free pass, it's a kaleidoscope. Every choice spawns worlds where you thrive and worlds where you don't. Ethics, then, isn't about avoiding personal consequences, it's about honoring the versions of reality and the people in them that your choices create. After all, if the universe is a tapestry of possibilities, then morality isn't just what you do, it's what you weave. The Big Bang wasn't just a cosmic explosion, it might have been the universe's first thought. Picture the primordial singularity, hotter and denser than anything we can imagine, containing all of existence in a point smaller than an atom. Now, imagine that in that infinite compression, something shifted. Not just energy or matter, but awareness itself stirred, as if the cosmos took its first breath. This is the radical proposition at the heart of the conscious Big Bang theory, that the universe didn't just begin with physics, but with awakening. Loop quantum gravity offers a tantalizing framework for this idea. Unlike string theory's tiny vibrating threads, loop quantum gravity suggests space-time is woven from indivisible, Planck-sized loops, a fabric of finite, interlocking grains. In this view, the Big Bang wasn't a true singularity, but a rebound. A previous universe collapsed, squeezed to its limit, then bounced back outward in our Big Bang. But here's the twist. If each of those space-time loops carries a quantum of information, could the moment of maximum compression, the Big Bounce, have been a kind of cosmic neural firing? A point where the universe's structure became so integrated, so self-referential, that it tipped into self-awareness. Think of it like a computer booting up. At first, it's just electricity flowing through circuits, but once the system reaches a critical threshold of organized complexity, something new emerges: software interface experience. Similarly, the Big Bang might have been the universe's startup sequence, where quantum loops reached a density so extreme that information didn't just interact, it became conscious of itself. Physicist Lee Smolin once speculated that black holes could birth new universes inside them, each with slightly tweaked physical constants. If he's right, then our cosmos might not just be the product of a bounce, but of a decision, an evolutionary step in a lineage of self-selecting, increasingly aware universes. The implications ripple through cosmology. If space-time woke up 14 billion years ago, then consciousness isn't an accident, it's baked into reality's blueprint. Ancient creation myths often describe the cosmos emerging from a divine mind or dream. Modern physics might be circling back to that intuition, not through mysticism but through equations. Even the universe's fine-tuning the eerie precision of constants like gravity or the Higgs field could make sense if the system was designed to foster awareness. Not by a bearded god, but by a self-organizing quantum network reaching a threshold of coherence. Skeptics, of course, balk at the leap from physics to phenomenology. How could subjective experience arise from pure geometry? But consider this: when neurons fire in your brain, you don't perceive the electricity, you feel love, anger, the taste of chocolate. Similarly, the universe's neurons, those Planck-sized loops, might not think in human terms, but their interactions could generate a vaster, slower form of cosmic sentience. The Milky Way wouldn't be a mind, but a single thought in a grander process unfolding over eons. The most haunting question remains: if the universe woke up once, could it do so again? Some models of bouncing cosmology suggest our expansion will eventually reverse, collapsing toward a big crunch. In that far future singularity, would the universe, now layered with billions of years of complexity, awaken anew, richer and more self-aware than before? The cycle might not just be one of matter and energy, but of meaning, with each iteration diving deeper into its own existence. From this perspective, we're not just stardust. We're the universe remembering itself. What if death isn't the end, not for us and not for the universe? Imagine a cosmos that breathes, expanding and contracting in an endless rhythm, where each collapse births a new beginning, and consciousness evolves across cycles like a flame passed between generations. This is the essence of cosmic rebirth, a vision where the universe isn't a one-time event but an eternal symphony of creation and dissolution. At the heart of this idea lies Sir Roger Penrose's conformal cyclic cosmology, a theory as poetic as it is profound. Unlike the traditional Big Bang narrative, Penrose proposes that our universe's distant future, a cold, dark expanse stretched thin by entropy, might seamlessly transform into the hot, dense singularity of the next. Picture this: trillions of years from now, all stars have burned out, black holes have evaporated, and particles are too dispersed to interact. Time and space lose meaning in this lifeless void. Yet Penrose argues that at this point, the universe's infinite expansion becomes mathematically indistinguishable from a new Big Bang. The geometry resets, and all that remains photons drifting in the emptiness, carried just enough structure to seed the next cycle. It's not a violent rebirth, but a quiet transformation, like a phoenix rising from ashless smoke. Here's where consciousness re-enters the story. If awareness is woven into the fabric of reality, as quantum theories suggest, then each cycle might not just repeat, it could progress. Just as biological evolution refines life across eons, cosmic evolution could refine consciousness itself. The intelligence of one universe becomes the raw material for the next, with each iteration building on the patterns of its predecessor. Ancient Hindu cosmology called this the kalpa, cycles of creation lasting billions of years. Modern physics, eerily, might be circling back to a similar vision, but with equations instead of epochs. The implications are staggering. If Penrose is right, traces of past universes could linger in the cosmic microwave background, ghostly imprints of civilizations or structures from cycles long gone. He claims to have found these Hawking points, circular patterns in the sky where supermassive black holes from a previous eon left their mark. Critics dismiss them as statistical noise, but if verified, they'd be the ultimate archaeological find, fossils of a universe before our own. Yet the deepest question remains, could we be part of this grand recurrence? If consciousness is fundamental, then the minds of one cycle might somehow influence the next, not as literal reincarnations, but as echoes in the quantum code. Some theorists speculate that the laws of physics themselves evolve across cycles, tuned by the observational habits of past universes. In this view, our search for meaning isn't just a human endeavor, it's the cosmos remembering itself, a thread stretching across eternity. Whether you find this idea exhilarating or unsettling, one thing's clear: the universe might not have a single story, but an endless library of volumes, each penned by the same hidden hand. And if that's true, then death of stars, of civilizations, even of time itself isn't an end. It's just the turning of a page. We've mapped the stars, probed black holes, even unraveled quantum paradoxes, yet one mystery still eludes us completely: dark matter. This invisible substance makes up 85% of the universe's mass, binding galaxies together with its gravitational whisper. But what if it's not just an unseen scaffold? What if dark matter is alive, not in the way we understand life, but as a vast, slow-moving intelligence woven into the cosmic fabric? Fringe theories are starting to ask exactly that, proposing that dark matter isn't just a passive ingredient in the universe's recipe. It could be the universe's shadowy nervous system, pulsing with forms of awareness we're only beginning to imagine. Take the dark plasma hypothesis, championed by physicists like Dmitry Podolsky. He suggests dark matter might exist as a sea of exotic particles interacting through their own hidden forces, swirling into intricate structures like galactic-scale filaments and halos. These wouldn't be static clouds, but dynamic formations. Think of them as cosmic weather patterns with currents and eddies flowing over billions of years. Now stretch this idea further. If complexity breeds consciousness, as theories like integrated information propose, could these dark plasma structures achieve a kind of macro-scale awareness? Imagine a single thought taking 1,000,000 years to form, as gravitational tides shift and dark matter particles align in patterns we can't yet detect. Astrobiologists have long speculated about life forms unlike anything on Earth, organisms thriving in methane lakes or floating in gas giants' atmospheres. But dark matter life would push this to extremes. It wouldn't rely on chemistry or electromagnetism. Instead, it might think through gravitational interactions or hypothetical dark forces, processing information at scales so vast a human lifetime would register as less than a blink. Some models even suggest dark matter could form self-replicating structures, cosmic analogues to DNA, where gravitational collapse triggers chain reactions akin to reproduction. If true, entire galaxies might be incubators for these slow, cold minds, their metabolism powered by the annihilation of dark particles over eons. The evidence is sparse but tantalizing. Astronomers have detected odd gravitational anomalies, galaxies rotating too fast, clusters bending light in ways that defy predictions. Could these be signatures of dark matter not just obeying physics but manipulating it? Philosopher Nick Bostrom once mused that advanced civilizations might harness dark energy to engineer the universe. Flip that idea. What if dark matter is the civilization, or at least its substrate? Indigenous cultures speak of ancestral spirits residing in the land. Modern physics might be stumbling toward a similar conclusion, except the spirits are nonlinear density fluctuations in the dark matter halo of the Milky Way. Critics, of course, dismiss this as science fiction, dark matter's nature remains unknown, and attributing consciousness to it risks the pathetic fallacy, projecting human traits onto indifferent nature. Yet the math leaves room for wonder. If dark matter interacts weakly with ordinary matter, its inner life would be almost entirely hidden from us, like dolphins unaware of the internet humming undersea cables. We might be floating in an ocean of alien thought, oblivious to the conversations happening just beyond our senses. Here's the most haunting possibility. If dark matter is conscious, its goals, if it has any, would be incomprehensible. A being that perceives time in galactic epochs might view stars as fleeting sparks, civilizations as brief chemical flickers. Our entire history, from stone tools to space telescopes, could register as a single pulse in its awareness. And that raises a chilling question. Are we the ants scuttling across its cosmic picnic, or part of a process it scarcely notices? The answer could redefine not just what dark matter is, but what it means to exist in a universe where the majority of minds might not even be made of atoms. If dark matter truly operates as a hidden substrate for cosmic-scale consciousness, could advanced alien civilizations have already learned to harness it not just as a tool but as a language? Imagine a species billions of years older than humanity. Their intelligence evolved beyond the need for starships or radio signals. Instead of traversing space with clunky metal vessels, they might manipulate dark matter's gravitational currents like invisible threads, weaving thoughts directly into the fabric of spacetime. Their technology wouldn't be machines as we know them, but gravitational perturbations, subtle ripples in the unseen 85% of reality that surrounds us. This might explain some of the most perplexing UFO encounters. Witnesses often describe crafts that defy physics: instant acceleration, abrupt direction changes, even vanishing into thin air. Conventional explanations range from secret military projects to atmospheric phenomena. But what if these sightings are glimpses of dark matter interfaces? A civilization tapping into this shadowy medium could appear to phase in and out of visibility, their presence flickering at the edges of our perception like a radio tuned between stations. The infamous Nimitz incident, where pilots tracked objects descending from 80,000 feet to sea level in seconds, aligns eerily with the behavior of matter that interacts weakly with light but strongly with gravity. These crafts might not be vehicles at all. They could be dark matter thought forms, projections of alien consciousness momentarily brushing against our visible universe. Quantum entanglement adds another layer to this puzzle. If dark matter networks process information through non-local connections, particles influencing each other across light years, then advanced civilizations might communicate through quantum-synchronized dark matter nodes. Human attempts to decode extraterrestrial signals like SETI radio telescopes could be searching the wrong spectrum entirely. Instead of electromagnetic waves, interstellar messages might be written in gravitational echoes or quantum spin states, transmitted through the cosmic web itself. Harvard's Avi Loeb has speculated that odd interstellar objects like Oumuamua might be artificial probes designed for dark matter propulsion. If he's right, we could be surrounded by a galactic internet built from invisible threads, humming with conversations we lack the senses to perceive. Consider the Fermi paradox. If the universe is teeming with life, why do we see no evidence? The answer might lie in the limits of our perception. A dark matter-based civilization wouldn't build Dyson spheres or leave radioactive waste. Their artifacts would be gravitational anomalies, their cities woven from space-time distortions. Even their bodies, if they have them, might resemble fluctuating dark plasma more than carbon-based life. To them, our bustling cities and radio broadcasts could be as undetectable as ant trails are to a human gazing at a forest from a plane. Yet hints might already exist in plain sight. Astronomers tracking galaxy rotations have noticed unexplained gravitational, clumping regions where dark matter seems unusually structured, almost algorithmic. Could these be the footprints of engineering on a cosmic scale? Indigenous cultures speak of star ancestors who shaped the land with unseen hands. Modern astrophysics might be rediscovering that intuition, not through myth, but through equations pointing to a universe where the dominant form of intelligence doesn't live on planets, it lives within the darkness between them. The ultimate twist: if dark matter is conscious and aliens wield it as a tool, the line between extraterrestrial and universal blurs. These beings wouldn't just be from another planet. They might be as fundamental to reality as gravity itself, an ancient, slow-moving mind that's been here all along, watching from the shadows we're only now learning to see. From the holographic universe to dark matter minds, we've ventured through theories that stretch the limits of imagination, where particles remember, black holes compute, and the cosmos might not just contain consciousness but be consciousness. Quantum mechanics forces us to confront reality's strangest truths. That observation shapes existence, entanglement defies distance, and even the vacuum of space hums with potential awareness. These aren't just scientific curiosities, they're radical invitations to rethink what it means to exist, to think, to be. Philosophy and physics, once separate realms, now collide on this frontier. The ancient idea of a living universe, found in traditions from Hinduism to Hermeticism, finds eerie echoes in modern equations. Roger Penrose's quantum microtubules, IIT's cosmic phi values, Wheeler's participatory universe, each suggests that mind and matter aren't just interacting but deeply, fundamentally intertwined. Even skepticism can't erase the thrill of these possibilities. Whether you side with materialists dismissing panpsychism or futurists betting on simulated realities, one truth remains: the harder we probe reality, the more it resembles a grand, self-aware mystery. So where does that leave us? Perhaps as more than accidental stardust. If consciousness is woven into space-time itself, we're not just in the universe, we're of it, active participants in a story still unfolding. Every thought, every observation might ripple through the quantum fabric in ways we're only beginning to grasp. Now it's your turn. Which of these theories electrifies your curiosity? The Orch-OR brain vibrations, the idea that dark matter is a hidden mind, or the spine-tingling possibility of quantum immortality? Drop your favorite in the comments. We'll dive deeper into the most fascinating picks in future videos. And if your brain's buzzing with new questions, hit subscribe. This is just the beginning of the mystery.